Alright, in this video we're going to find how to integrate using a calculator, and the problem says on the calculator find the integral from 0 to pi of sine of x dx using 10 rectangles. So using 10 rectangles, what we're going to do, I'm going to type this out, is we're going to do a sum of the sequence of 10 rectangles. So what does that say? Well, so note, n equals 10. Okay, so n is equal to 10. So therefore, my delta x, my width, is going to be equal to pi minus 0 over 10. So it's going to be pi over 10. So let's put pi divided by 10. Okay, that's the width of each interval. And to do 10 rectangles, we have to do the sum of the sequence of sine of x, then comma, x, and then we have to decide if we're going to do a right-hand or left-hand sum. Let's say we do a left-hand sum. We will start at 0, and we'll go to pi minus pi over 10. So pi minus 1 width, so minus pi over 10, and then comma, and the width of each interval is pi divided by 10, and then we close that twice, and we times that by pi over 10. So that's how you would actually do it on the calculator. Let's pull up the calculator. To find the sum sequence, we go second 0, the catalog. You scroll down to S, or you click LN, and you can scroll down to SUM. So SUM is here. Hit enter, and then the sequence. So you go sum second 0 goes back to catalog, and you scroll up till you see S again. Sorry, I hit natural log, and then scroll to S, SEQ this time, sum sequence, and then you put the function, the sine of x, close it off, close that parenthesis, then comma x, then comma 0, then comma pi minus pi over 10. So the second, this caret here, second that is pi, the minus 1 width, so minus, I'm going to put parentheses, pi divided by 10. Close that. So that's the end, comma, and then we put the width, which is pi over 10, pi divided by 10. Then we close that off twice. And then we times by pi divided by 10. So what this is going to give me is the left-hand sum of 1.866. So the area from 0 to pi approximately is equal to 1.866. That's an approximation, 1.886. It's an approximation based on the calculator summing up the left-hand sum of those rectangles. Now, if you want to do this actually on the calculator to get the accurate sum, remember, if as n goes to infinity, you get a more accurate sum. But if you want to do this on the calculator, we need to graph the function. So if we graph this, we go y equal, and we put sine of x. And by the way, always make sure your mode is radian, as you see up here. Okay, so make sure you're in radian mode. So we have y equals sine of x. And I'm going to graph it between 0 and pi, or maybe a little bit further. So my window I'm going to set up maybe from 0 to, let's say, 3 pi over 2. So a little bit further, just so I go out a little bit further. And my scale, I'll make it in terms of pi over 2. So pi divided by 2. So I set up my x parameters, and all I have to do is click zoom and 0, and it will graph this function for me. You can see it start to graph the sine function between 0 and 3 pi over 2. Okay, but we only want the area between here and here, underneath, so this area here. So how do you do that? You go second trace, and you scroll down to the integral sign. So this is going to give me the area right here. Hit enter, hit 0, enter, as the lower limit, and the upper limit is pi. Hit enter. And then you see it's actually summing up a lot of rectangles to give you the area of 2. So we were a little bit off with our left-hand sum of 10 rectangles, 1.886. The actual area is 2. And you could try this using the right-hand sum and see maybe you'd get something over 2. And if you average them, you may have got something that's equal to 2. So that's how you find the area or the integral using the calculator.